Hi, I'm Bonnie Gulas-Wroblewski, and I'm here today to talk to you about the species status assessment that's being conducted by U.S. Fish and Wildlife in conjunction with Texas A&M Natural Resources Institute for the plain spotted skunk. First, I'm going to discuss why we're even conducting an SSA for the plain spotted skunk, so reviewing the initial Endangered Species Act petition and the subsequent 90-day finding by U.S. Fish and Wildlife. Then going over what are SSAs and how are they conducted. So the basic concepts of viability and the 3 R's, which are resiliency, redundancy, and representation, and how those feed into the analyses that we're performing. I keep saying we, so I'm going to talk about who's actually conducting the SSA and the roles and responsibilities of the various teams that are involved. And then during what time period are we conducting this SSA? So going over the timeline and where we are within it. And then how you can assist in the SSA process and make sure that we're using the best available knowledge that we can when we're conducting our analyses. So why are we even conducting an SSA at this point? Well, in 2012, the plain spotted skunk was petitioned for listing under the Endangered Species Act. And as you can see from this map on the right of your screen, what we're talking about is the taxon of eastern spotted skunk that runs from Ontario, Canada, down through Tamaulipas, Mexico, along the Great Plains region. And you can see that Spilogale, putorius, interrupta. Right now, there's some question as to whether this is a subspecies or a full species. So throughout this talk, I'm just going to refer to them as the plain spotted skunk. But in either case, it's a distinct taxon, and it was petitioned for listing in 2012 at the beginning of the year. Later in the year, there was a 90-day finding released by the U.S. Fish and Wildlife Service in which they determined that a review of the plain spotted skunk was necessary to evaluate whether listing was warranted or not. It was made on the basis of present or threatened destruction, modification, or curtailment of its habitat or range-wide, and the potential for disease or predation to affect the species as a whole. So what are species status assessments? I keep talking about SSAs. Well, they're part of U.S. Fish and Wildlife's ongoing effort to improve the implementation of the Endangered Species Act and more generally to enhance conservation success. It's very important that they're focused, they're repeatable, and they're rigorous assessments of a species' ability to maintain self-sustaining populations over time. So assessing the viability of a species, or in this case, a subspecies. They were started around 2015 to really become a standard evaluation tool for the U.S. Fish and Wildlife Service. And they're based on the best available scientific and commercial information available at the time regarding the life history, biology, and threats current and future to the species or subspecies. So how are SSAs used? Well, Fish and Wildlife uses them as a foundation for all the Endangered Species Act decisions they make regarding that taxon. So this includes listing determinations, consultations, grant allocations, permitting, recovery planning, anything that is dealing with a U.S. Fish and Wildlife decision regarding that taxon is really based strongly on the scientific report. So what is an SSA in terms of the framework of how they are conducted? Well, the purpose behind them is to describe the viability of the species in a way that supports Endangered Species Act decisions. And I'll define viability in a later slide, but the first step towards getting there is to synthesize the biology and ecology of the taxon under review. And this is a step at which you're looking at that taxon's needs within a biological and ecological context. That allows you to jump to evaluate their current condition, so looking at the current availability or condition of those needs. And this is a step at which you're identifying any kind of threats or influences that are acting on those species needs, and then also delineating any populations that exist, asking yourself if there are representative units that you can evaluate later on in terms of representation. And this allows you to move forward into an evaluation of the future species condition. And this is when you're looking at the future availability or condition of the species needs that you've established in the first step. This is when you're evaluating what risk factors are important to carry forward or that you can even carry forward, and what's the appropriate time frame that you're using to project those species conditions forward. So this time frame has to be appropriate not only to the taxon that you're evaluating, but also to those risk factors that you're carrying forward. And I'll talk about all of this in more detail later. But moving on to the definition of viability. We define viability as the ability of the species to sustain populations in the wild beyond a biologically meaningful time frame. It's important to remember this is not a static concept. It's a continuous measure of the likelihood that the populations will be sustained over time. And in order to assess the viability over time, we deconstruct the viability concept into what we are calling the 3 R's. So these are the conservation biology principles of resiliency, representation, and redundancy, which I'm going to review right now. So the general concept behind viability is that a species with a high degree of resiliency, representation, and redundancy is better able to adapt to any kind of future changes it may encounter and to tolerate catastrophes, environmental stochasticity, and stressors, and then therefore it typically has a higher viability and likelihood to sustain itself over time. So the first concept we're going to talk about is resiliency, and this is measured and evaluated at the population level. And this is the ability of the species to withstand environmental variation and stochastic events. And for this, we're really looking at the populations or any kind of divisions of resiliency units of that taxon over time. So we're looking at it historically and how that affects their current condition as well as their current conditions and into the future, so future conditions of the resiliency. And this is for any kind of defined populations or analysis unit. So going over some of those defining factors, there's 2 defining factors that really drive resilience of populations. One are habitat factors. So for our plain spotted skunk, these are going to be things like density of brush cover or rocky outcroppings, availability of den sites. And then the second is population factors. So these are things like population density, evidence of reproduction, dispersal, anything that's really a population dynamic. And if you look at the bottom conceptual model of factors that are influencing the resiliency of lynx, you can see you have habitat availability is built into that, as well as immigration from Canadian populations, and that's the population factor. So you really have this interplay of both habitat factors and population factors affecting the resiliency of a species or subspecies or taxon you're evaluating. We're also looking at the influences on viability at this point. So we're identifying all of the potential threats, stressors, influences. So, in terms of the plain spotted skunk, this would be things like development, climate change, forest management, anything like that. It's important to remember that these are negative but also positive influences. So things like conservation strategies may be a positive that you're building into your influences. These are the influences that are going to help define your scenarios as you move forward and evaluate current and future conditions. And they're also going to allow you to really target any kind of influences that are really important to take into the future context. So again, looking at the lynx diagram, you see that you have negative influences like climate change, as well as positive ones like forest management specifically for lynx. Moving on to representation. Representation is measured now at the species level, and it's the ability of the species to adapt to near-term and long-term changes in environmental conditions. So this is also known as adaptive capacity of species, a lot of times in conservation biological circles. So basically what it is if you have 3 units of some kind of variation within the species, so I'm going to talk about these future, but let's pretend this is genetic right now. And you have all of your little skunk people in 1 unit of that type of variation. Well, this is really low representation, right? Because you don't have those 2 other units of variation covered. However, if you redistribute your spotted skunks and you get each of those units of genetic variation, in this case represented, then you have high representation. So representation can really be thought of as having different types of a species or taxon. And these can be genetic groupings, like I just used in my example, ecoregion use, habitat type use, different life history strategies or behaviors employed by the taxon you're evaluating, or in some cases, they may be a single unit, and you may not have any kind of representation units to use. The typical representative units that you'll see in SSAs are genetic populations, ecoregions, and watersheds. So you can see that on the example to the right. This is the Mill Creek crayfish. And you can see that they've broken down the representative units really based on the watershed catchments. So it's not any kind of genetic differentiation or habitat usage differentiation. It's kind of the bigger concept of using the habitat. And that's used a lot of times when we can't evaluate any representation directly. So this is when we don't have any specific ecological or genetic data or behavioral data on the species. So we have to base our representative units on the extent and variability of habitat characteristics across the range of the species. Moving on to redundancy. Redundancy is also measured at the species level, and it's the ability of the species to withstand catastrophic events. So this is measured by the number of populations and their distribution throughout their range, and also within representative units. So there's a lot of interplay between redundancy and representation when we're conducting our SSA analyses. As you can see from this example right here, if you consider each of these circles a different habitat type, when you're looking at this in terms of representation, there's not a lot of representation of your plain spotted skunks across this area. However, there's a lot of redundancy in the purple region. When you redistribute your skunks accordingly, you have a little more representation here. It looks good. You're across all three circles, but your redundancy has declined in the purple region. And then when you redistribute your plain spotted skunks accordingly, you have pretty even redundancy and representation across the region. And so this would be the most viable population in terms of looking at redundancy and representation if you're not taking into account whatever resiliency may be. So jumping to future scenarios, the primary goal is to compare the current condition using the 3 R's we just discussed to a future condition, also using the 3 R's, under several plausible scenarios to assess their viability over time. You're carrying forward important influences on their viability, and these are negative things, urbanization, climate change, habitat degradation, as well as positive measures, so habitat protection, possible reintroduction programs, or reduced take and protection of the species itself. You're going to look at multiple scenarios to capture any kind of uncertainty. So these are uncertainty not only in the risk factors you're looking at, so multiple climate change models. If you take a look at the example to the right, and these are for the key deer, and you have the comparison of different climate change models as far as how sea level rise will affect them over time. And as you can see, you're using different scenarios to really couch that uncertainty when you're looking at that risk factor. You also want to use different scenarios to look at the uncertainty in the species response, because we don't know how key deer, for instance, are going to respond necessarily to sea level rise at each of those junkets over time. So you want to give a range of possibilities to evaluate. You also want to make sure that you're using an appropriate time frame to project out these future scenarios. So this is not only based on the species itself, so looking at the lifespan perhaps of the species and generation times, but also the time scale that influences themselves. And again, these are both the positive and negative influences. And you're going to have to address the uncertainty in the future environmental conditions as well as the species response to those. So again, looking at this example to the right of the key deer curves, if you look out maybe to 2030, they don't have a huge response that's different, but when you look out to 2090, you can see that between those two models, there is a very significant difference in how the population is doing. So as far as the future conditions analysis itself, the complexity of that analysis will match the complexity of the taxon you're evaluating and any of the information available for that taxon. So for instance, if you're working with a species where you know a lot about its population dynamics, its habitat use, and how influences affect it now and will likely impact it into the future, you can do things like PVAs, GIS models, and other statistical analyses to really come up with a quantitative projection into the future. However, if you don't have any information about that species or how influences are going to affect it into the future, then you're going to rely more on expert input to come up with qualitative projections of future scenarios. And an example of that is the black warrior water dog, which you can see the table below. There's not really quantitative measures of its resiliency, but more qualitative in terms of moderate, high, presumed extirpated. It's really important at this stage to only assess scenarios that are plausible. So we're not doing things that are, alien invasion, How is it going to react? These are things that within the realm of possibility and probability are going to happen. We're going to look at the 3 R's under each of those scenarios individually so that you're getting different projections of what may happen along a range of possibilities. So now that I've discussed the SSA process, who's actually conducting the SSA? Well, this SSA is actually led by the U.S. Fish and Wildlife Midwest Region 3, who've contracted Texas A&M Natural Resources Institute to help out. The core team are the people who are involved in the day-to-day writing and decision-making regarding the SSA. These are the people synthesizing the science, writing the SSA, coordinating with experts, conducting all those analyses I discussed, and ensuring that it's done in a timely manner for delivery to the recommendation team. That involves a team of people from Fish and Wildlife Service, who's headed up by Vonham, and a team from Texas A&M NRI, which I'm heading up. And then we have our expert and technical teams, and I should say thank you to you all because we've already been working with both in the process of writing our SSA. So these teams are filled with people who have specific expertise or knowledge that benefits the SSA directly. So the expert team, we've already had you fill out elicitation questions and provide us data, a lot of the unpublished data, to help us really frame our SSA. And as we move through the process, we'll be contacting people for specific types of data or asking them their advice as we move through our current and future conditions analyses, or maybe looking over certain chapter drafts as we go through based on their expertise. We also are going to have a peer review team that you have not been notified yet, so nobody out there hopefully is listening too carefully because any of you may be contacted for serving on our peer review team. But the peer review team we've been trying to keep as separated from the SSA writing process as possible so they can really provide an objective review for the final draft before it goes out to our recommendation team. So now to give you an idea of our timeline, we had our internal kickoff and sent out letters of invite at the beginning of May. We had our external kickoff and contacted our expert and technical teams in late May, and then started the SSA writing, analysis, review, and revision process in hopes to have a final draft complete in order to send out to external review by our peer reviewers and state partners by late January 2022. That's so that we can have a recommendation team meeting internally in spring, hopefully of 2022. And that way we can get out a 12-month finding in September 30th of 2023. That's because this SSA is on a work plan for fiscal year 2023, so that we're hoping we can get our springtime recommendation team meeting in place in order to account for any kind of listing decision that they come up with, if it's warranted. That will give us plenty of time to develop a listing rule, potentially a 4D rule if recommendation is to list as threatened, and then propose critical habitat, which will involve economic analysis if prudent and determinable. And then that way, that will bring us up to our September 30th timeline. Just looking at where we are right now in the process, we're right here. So we're actively writing and doing our analysis in the SSA process. So how can you help now that we've already started the SSA process? Well, we're still interested in any location data to the county level. So if you have any of that, please do share it. We're very interested in getting it. And any information related to the influences on their viability, so either currently or in the future. So if you know of any adverse threats or stressors, you know if there's a new development that's slated to be built on top of plain spotted skunk habitat that you know they exist in, please do let us know. This is also beneficial measures, so if there's conservation initiatives happening on the ground like habitat protection, we're also very interested in that. And then any other information that you have about plain spotted skunks, please feel free to share it and we'll incorporate it as best we can into the SSA depending on where we are along in that process. You can send anything you have in any format you have to me. This is my email address. Hopefully you'll get a copy of these slides so that you'll have our contact information. And please, when you contact me, always CC this plain spotted skunk email. That's just to make sure that we have all of our information and correspondence in one area for possible FOIAs. So thank you all for being here today, and a huge thank you to Clint and Andrew for the invitation to participate in this virtual meeting. It was great to have a chance to talk to you all about SSAs and this specific SSA. I also wanted to give a special big thanks on behalf of all of us on the SSA core team to everyone who's working on our expert team, everyone who's already shared data with us, people that we will be tapping in the future to be peer reviewers, and all of you for contributing to the conservation of eastern spotted skunks in whatever way you're doing it. Thank you all so much. And now it's time for questions.